Hello YouTube, De-bodgery here. Welcome to EV Components Review. It has been a long ass time since I made a video last. And the reason why is I told everybody I was moving to New Jersey, or that I was moving, and I did, to New Jersey, and was there less than a month. Had packed away my Prozac because I deal with some pretty good PTSD and depression and couldn't find it. And so anyway, I went cold turkey off of Prozac and reacted rather badly to it. And my business partner threw me under the bus, or at least that was the excuse he used, was that I was crazy. Um, and yeah, stole all of my property, something to the tune of $60,000 worth of tools, EV hardware, EVs, battery packs, motors, controllers, cameras, you name it, all stolen. Yeah, he had rented a house for me, kicked me out of that, basically left me homeless and devoid of all of my property. And so, yeah, I went to New Jersey with a 26-foot truck, packed full of all of my property. And less than 30 days later, I was turning around and heading back with a 5 foot by 12-foot trailer with what little of my property I still had left and my SUV. Everything else was stolen. So anyway, yeah, I haven't made any content in a long time and didn't have anything and still don't have anything. I have a soldering iron and a couple other things. I have a plastic crate with some sockets and two EVs, and that's everything that I still have that's EV related or tools or whatever of many, 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 many years worth of accumulation of equipment that is now stolen by my now ex-business partner, Watt Wheels. So anyway, folks, I haven't made any content in a long time because I don't have anything to make content with or whatever. Yeah. I am literally bankrupted. I don't have anything to show for my trip to New Jersey other than lots of trauma and loss. However, while I was in New Jersey, I took a bunch of pictures of this XZS controller, which I forgot all about because, I was being thrown under the bus and being forced out of everything and, basically told to go live under a bridge. By the way, I'm keeping everything that you've got. Um, yeah, and go fuck yourself. So anyway, I took these pictures and forgot all about them. And so here is an XZS controller. I've been hunting for one of these things for well over a year, long before I ever went to New Jersey. And the reason why is because the kind folks over at KO Moto claimed that EBMX simply had copied XZS, and that the X9000 was an XZS clone. I knew that that was complete nonsense, but hey, let's see if I can't find one of these things eventually and do some content on it. So anyway, yeah, I took some pictures and it intended on doing some video back in New Jersey, but that never happened. And just recently found these photos again. So everything here that I'm going to show you is all going to be photo based, and that's going to be that. But yeah, the fact that so-called the X9000 and XZS are copies of each other, I would say that's highly explainable, and the reasons for that are highly reasonable and good, not bad. And that's typical for Moto to sling mud at somebody's product that's better than their own, which pretty much everything is. So anyway, yeah, there's reasons why everybody else doesn't blow up and Moto products do. So let me just scroll through a couple pictures here. You'd get a kit with parts like that in it. They come in a variety of different colors. Yeah, it's actually CNC machined aluminum, which is kind of cool. Yeah, here's a couple of stock photos I found of the board. Here's the pinout for the connector if anybody cares for that. Yeah, so anyway, on board is a 12-volt DC to DC converter, which is super cool, and I'll show you that on the logic board in a minute. But yeah, you actually get power for that coming out of here for different things. Yeah, there's some details in here that are actually pretty nice. Anyway, there's their power stage. So let me move on to the photographs that I have taken of things. That's a prototype power stage, but yeah, still, it's pretty nice. All right, so anyway, let me move on to the logic board. So here's the picture, one of the pictures I took. So every time I see a logic board that's got current sensors on it, two or three of them, there is a pretty much a 100% chance that that controller uses field-oriented control, which is good. And even the basic stuff like say FAR driver, KO Moto, Vodal, which are all based on the STM32 F103 CPU, they do have basic FOC motor control. They do. but it's a very limited scaled down version because of very limited CPU power. Whereas, like, say, VESC or Nuclear or ASI, they have the full FOC feature set because they have enough CPU power to handle it. And this is kind of like a halfway between the STM32 F103 and the F405 as far as input and output signals. It's got lots of that. It just doesn't have the speed and the processing power of the F405. So this CPU right here, this is the STM32G06. Let me just verify that. I did look it up. I'm pretty sure that's what it is. Yeah, the STM32G06, and you can see part of the part number in there later on. Anyway, so it is a 64 megahertz processor, whereas the STM32F405 is 168. Let me look that up real quick. I have that pulled up as well. I think that's right. Uh, yeah, 168 megahertz. So, basically three-ish times faster processor, just clock speed wise, versus this guy. So the VEST controller is going to be able to process data, significantly faster, but it's got a little bit less I/O than this does. So, this has got more inputs and outputs on it than the VEST CPU has, but the VEST CPU can internally handle a lot more data. So it's still the better processor than this is. But this is kind of like halfway in between, like the Vodal, Far Driver, KO Moto stuff, and VESC. So it's going to be pretty decent. It's going to probably have a much more robust FOC feature set than say those other guys will, but it won't be as good as VESC. So kind of a halfway in between, if you will. And there's some nice attention to detail here. So let me talk about a few of those things. So I don't know why these are here, but there are two linear regulators on this logic board. But there is also a DC to DC converter board, which solders down to this pin header and this one over here that's got your 12 volts, 5 volts, and 3.3 volts on it. So I don't know what these two little linear regulators do beyond that. Something. I just don't know what. Also, over here, you'll see a DC to DC converter there, and it's got a fuse for it. And in that pin out I showed you, that was for that 12 volts out. Well, that's what this provides. This provides the 12 volts for that. So anyway, you've got an onboard 12 volt DC to DC regulator for external use. That's kind of a cool thing. There are other people that do this. For example, 3Shul does, EBMX does, STR, the STR 500 does. Um, yeah, I'm sure there's somebody I can't think of right now, but there's a few controllers that include a small onboard DC to DC for external powering of stuff. And so I'm kind of glad to see this. This is a purely Chinese development, no Western involvement as far as I know, and they've included one on here. And all I can say is good for you, XZS. Definitely like seeing that kind of thing. Um, all the inputs are protected, so you can see all these little black parts here. Those are TVS diodes. That's for protecting all the inputs and outputs so that, external surges and things like that are supposedly suppressed and protecting the internal electronics from external bad stuff happening. So definitely like seeing that kind of stuff happen. The connector here shouldn't be soldered onto. There is a cable that plugs in there. This came off of a Chinese-made EV that had come into the Watt Wheels shop, and they had soldered the wires on, and then they did a really crappy job of it. So I was taking this thing apart to fix all that stuff, and of course, then I got booted from the shop and never did any of that work. So anyway, I can't really speak to all that stuff, why they did such a bad job, but they did. All right, you'll notice these three resistors in series right here. This is kind of a clever little bit of kit. And then it goes to this TVS diode as well. So the idea here is to be able to drop battery voltage significantly, and that's what those resistors are doing, and then do some protection with this TVS so that you can then monitor battery safely with low voltage electronics. So that's what this little bit right here is about, if anybody cares. I've seen this done before on other things. Yeah, it's a very simple way to take high voltages and convert them down to low voltages, and still be able to get some decent readability from it. All right, what else do I want to show you from this picture? Oh yeah, so these yellowish caps and these black ones are all the SamX on brand, which I'll show you a picture of those later. but they're all 160 volt capacitors. These ones are 120 UF, and these ones are 150 UF. And as you can see, there's plenty of them all over the board. If there is one disadvantage to this two-board design, i.e. logic board with the capacitors on it and a power stage with just ceramics on it, is that your DC bus noise has further to travel before it gets filtered out. It's much better to have your electrolytic capacitors at the DC buses rather than up on the logic board. But these capacitors are not in any way, shape, or form part of a current path. They are not flat. They are not. Uh, they are uh, they are completely just for filtering. The copper that's in this board is just for these capacitors, and that's it. All right. So this up here is battery plus and battery plus, and this down here is battery minus underneath there. And there is a copper plane inside the board that gets from the underside of these boards to all these capacitors for battery plus, and then the bottom side of the board, which I'll show you in a minute, does the same thing for battery minus. So anyway, let's move on to the next picture. I'm not going to do a macro video of this. I don't have photographic quality good enough for that. These were quick snapshots I took, and I didn't get very many close-in pictures. So yeah, I can't do any of that stuff for you. So we're not going to do any macro videos. We're just going to do this overview, um, and that'll be that. All right, so here's the bottom side of the logic board. And so the whole bottom side of this board, so there's that battery minus and battery minus, and then there's this copper plane all across the bottom side of the board. So that is your RF backplane for protecting all the small electronics from all that noisy stuff coming off of the power stage. And so I'm glad to see that there. And these sets of holes and those right there are where the pin headers from the power stage pass through to the connectors on the top side of this logic board to get signals to the MOSFETs and temps, things like that. And this is battery plus, and then inside the board, there's a copper plane to get battery plus to the capacitors down here and any other place it needs to go. So anyway, this board has got an internal copper plane for battery plus, and then on the bottom board is battery minus copper plane. And then of course, there's the connector for all your external signals. All right. So let me show you the CPU. I don't like seeing stuff like this. So you can see these two really thin copper wires micro soldered onto the legs of the CPU. The STM32G06 CPU. Yeah, clearly there was a mistake made, an omission in the design or layout or something. Oopsie, we made a mistake, and so we're going to manually correct it. Yeah, I don't like seeing manual fixes like this, but here there are some. And, I've seen this on other stuff as well, and it always kind of makes me go, ah, don't do that, not good. But yeah, there they are. Yeah, that's not cool. You can see one of those sets of pins for the DC to DC converter, which I'll show you in a minute. There's the other set over there. And those two little linear regulators, which I don't know what they do. This one I can kind of read the part on it. It says 31117 on it, so I recognize the type of linear reg on it, but I can't read the voltage it says on there. Anyway, yeah, two little linear regs on there that do something. I just don't know what. Okay, so yeah, there's those SAM on capacitors, 150 microfarad, 160 volts. And the MOSFETs on the power stage are all 135 volt MOSFETs. And so this controller was designed to be able to run at a maximum of 24S. And whoop, I picked the wrong one. Set that back to where it was, because I want to use that later on for comparison with the X9000. There we go. So here's a DC to DC board. And there's three DC to DCs on here. So here's the main inductor. Here's the chip for that, and a MOSFET that's the 12 volt DC to DC for battery voltage down to 12 volts. And then right here, again, it's got a MOSFET for that. So this is the 5 volt DC to DC converter, and over here is your 3.3 volt DC to DC. I like seeing some large ceramic caps for cleaning things up, and got some decent electrolytics on here too for cleaning up noise on the regulated DC that these create. Bottom side of the board has a ground plane, so that's what this is on the bottom here. I like to see that too. And that connects from one side of it to the other. So yeah, complete ground plane across the bottom to keep any noise that's on this DC to DC converter board under control, so it doesn't affect the small electronics underneath it. And let's move on to the power stage. So this is what Christopher Kleinschmidt said that the X9000 is a clone of, or was the X9000 was copied from. And I would have to say that what he doesn't realize, because he's an idiot, is that actually that was a compliment, because this is actually a pretty damn good power stage. Yeah, it's a really good power stage. So anyway, here is battery minus across here, and that's a nice big hunkin' piece of copper across there. And yeah, right there you can see where the copper, where I cut away the chrome on the copper, so you can see the copper underneath. I'll zoom way in. See the golden color there? That's copper under there. So this is solid copper all the way through. It's also soldered down to the metal core printed circuit board, and the joints between the three pieces are soldered together as well. So good attention to detail, and everything is nice and straight, no voids underneath it. And I've got a picture where I can show you the edge on view of that. Unlike Komodo, where they do have voids underneath their copper, and it's a bodge anyway, and gaps between them, things like that. There's no hot spots in this current path. This is all done very well. Phase buses, the same thing. They're very tidy. This is soldered down to the metal core printed circuit board. It's not just screwed down. It's not just a butt joint. All this stuff is soldered down. Anyway, MOSFETs are very close to your battery minus and battery plus buses and to the phase buses, so that you have no losses, very low inductance, very low resistive losses, things like that. Everything here is done really well. Kind of hard to see in the blurry picture, but right there and right there is two thermistors for temp sensors. If this was VESC, which it isn't, you would have three temp sensors, one per phase. And when I show you the X9000 power stage, you'll see the three temp sensors. Um, my biggest complaint about this thing is not enough ceramic caps. So you got two here and two over here, and you've got enough space here to put 4 or 6 on either end, and I would have strongly recommended they did that. And I can't show it to you in this picture, but right up in here, you could have stuck 2 more on either side of that, in which case you could have had ceramic caps between the banks of MOSFETs, and that would have been good. So let's go on to the next picture. That's my big complaint about this thing. Otherwise, this is a pretty damn good power stage. All right, so now you can kind of see it. So down here, this is battery minus, and up there is battery plus. And anyway, the copper circuit pad underneath goes all the way down to here. So this is about 45 or 50 millimeters long, or wide rather, from the top of here down to here. It's a nice big wide copper trace underneath all of this copper bar. It's really nice and beefy. You can't really get much better than this. Then down here, battery minus, you can see this trace comes right up underneath here. It goes right up between the legs of this pin header, and then you can see it sticking out right there. So literally, this battery minus bus comes all the way up to there, within millimeters of the battery plus bus, and they didn't put any ceramic caps across here. And the same thing is true over here, and they put no ceramic caps across there. How hard would it have been to add a few ceramic caps there? Literally, you've got battery plus and battery minus millimeters apart, and you didn't put ceramic caps on there. But they didn't. But yeah, it's there. Anyway, yeah, they should have added ceramic caps there, and they didn't do it. You can see those two temp sensors when there and when there, the two thermistors. They are appropriately located, smack in the middle of phases, right where they should be for the best possible detection of temperatures within the phases. And so location is very good. This is something that you'll see less and less over time, at least if people keep using better and better gate drivers, and modern MOSFETs are at the point where you don't need these caps anymore. But you see these little ceramic caps that are each on each one of the MOSFET gates. This is needed less and less. And in fact, as far as the MOSFET is concerned, you don't need them at all. It just kind of depends on whether you're using good gate drivers or cheap ones or not. Whether you still need to have MOSFET gate capacitors or not. And really what they do is they slow down the switching times for the MOSFETs a little bit. And that's really all they do. So if you use good MOSFET gate drivers, you don't need them. If you use cheap ones, you do. So yeah, it's a compromise. If you look at, like, say, anything from Trampa, Tronic, Team Triforce, none of those guys will have those gate capacitors anymore because they're just really not needed because they're using, good Western gate drivers. Whereas if you see people with gate capacitors, it's probably because they're using cheapy gate drivers. So yeah, pay for it one way or the other. Use good gate drivers or use gate capacitors to slow things down to make them stable again. Anyway, I would rather just use good gate drivers personally, but that's a fairly minor complaint. If I had to use this power stage, which I would say yes, please, this is a really good one, then yeah, that's a fairly minor complaint. That's a really tiny complaint. Okay, yeah, here's the rightmost power stage, or I mean phase bus rather, and you can see the two ceramic caps. There's plenty of room here to add more, and they didn't. Yeah, definitely would have liked to have seen a bunch of them in there, and they could have easily have stacked them vertically across this whole space all the way down through here, and had six of them in there rather than just two, and they only had two. And it's the same way on the other end. They could have easily put six in there instead of two. And yeah, now you can see this piece of copper that goes right up in here, and it goes right up underneath that pin header and then stops right there. Can't really see that part because of the way the light is. And then here's battery plus. Could easily have put one or two of those ceramic caps across that little gap, and they didn't. So come on, guys. But again, this is still a really tidy power stage. I mean, look how close this copper is to these MOSFETs, and the copper, trace goes halfway underneath the MOSFETs. Totally covers the entire drain side of the MOSFETs, and the same thing with the other side. Here's battery minus. The copper comes all the way up underneath all these legs in here. And the phase bus is the same way. Phase bus is all across here, and then the actual copper for the stud is very, very close to it as well. Yeah, this is a very tidy power stage. Yeah, this is a really, really well laid out power stage. Whoever did this, you did a really good job. With the wish for more ceramic caps. Yeah, anybody who's doing a good job, they're going to do it a lot like this. Somebody who gives a concern, who gives a shit about their work, they're going to do it like this. And as a result, yeah, EBMX looks a lot like this. I can show you a bunch of vest stuff that looks a lot like this. So if they're copying each other, it's because if you're going to do a good job and make really tidy, good, tight power buses, and low loss, low inductance, low resistance, high current draw, current paths that make very little heat, you're going to do it like this. If I was going to design a power stage, oh wait, I have, and I did it like this. All right, so let me go back to that picture. So, just take a quick gander of that. And now let's go over to the X9000 power stage. So yeah, of course they look very similar. So yeah, and they're both 10 MOSFETs per phase. Um, so yeah, like this one here, they say 900 amps, and I think that's really what the X9000 can do. And yeah, and this is 100 volts, right? And the XZS controller is actually 24S, not 22S max like this is. So, it's got 135 volt MOSFETs in it. So it's actually got lower current MOSFETs in it than this does. So it can actually probably handle a little bit less current. I'd say probably 600 continuous rather than, 800 or whatever this can handle. But again, one, two, three current sensors because that's the best standard. Could use more ceramic caps, and in fact, in the version 2 of their power stages, they did ask me for feedback on their power stage, and so I gave it to them, and they did add more ceramic caps on their power stage, so the new ones have more, which makes them less noisy. They still didn't get any in here or in here, but yeah, this design didn't really allow for it, so they didn't. But anyway, yeah, so you do have more out on the edges, and the XCS does have the ability to be able to fit a few in here. But again, very, very tidy, very tight phase buses, battery buses, lots of copper where you want it, no gaps in the copper, continuous current paths, low inductance, low resistance, very, very low loss power stage. This is how you build a power stage, okay? And the fact that the XES and the EBMX power stage and many other ones are very, very similar like this is for really good reasons. Is because it's very, very tidy, very, very tight, low loss. So yes, of course, the X9000 power stage is going to look a lot like the XZS power stage, or XZS looks like X9000 or looks like a VESC power stage or whatever. It's because they're very low loss, very tidy, very good current pass, low inductance, exactly how you want it. So yeah, good job XES. As far as I know, they don't have any Western involvement with this development. This is all done by Chinese people, which all I can say is good job for you guys. You did a good job. All right, so if you look at the edge here, you don't see any voids in there between the copper. It's because XES gives a shit. They did a pretty good job. Attention to detail, and I think you can see that in another picture here. Yeah, there's no voids underneath here. I have an edge-on picture somewhere here. Yeah, you can kind of see it in there. There's no voids underneath. The copper is soldered down. Yeah, the MOSFETs are all straight. Things like that folks like Keomoto don't do. Yeah, MOSFETs are all nice and straight on this thing. Yeah, there we go. You can see that there's no voids underneath the copper. It's all soldered down. There's solder between the sections of copper. So everything is connected together very nicely. Yeah, this is how you build a power stage, folks. It just is. XCS did a good job here. So, folks, if you are wondering if you should buy an XZS, yeah, if you can get one of these things for, just a little bit more money than what you would pay for, like, say, a FAR driver, or, a Vodal, or God forbid, a Keomoto, I would say buy an XZS. Yeah, because it's definitely a better controller just hardware-wise than any of those are. Really would like to see the software, really would like to run one of these things, but I have not been able to actually buy one so I can play with it. So yeah, maybe in the future somewheres. But definitely like what I'm seeing from XZS. Decent design, decent design. Definitely better than most everything else I've seen out of China. Definitely lots better than most everything else I've seen out of China. So folks, I hope that helps you out. Yep, definitely like this work a lot. Let me go back over to that picture. I think that was one last thing I didn't say. So yeah, there we go. So you can see those MOSFETs, HYG05ON13s. From Hawaii. Yeah, somebody can correct me on how to say that because I certainly don't know how to say it. But anyway, these are 135 volt, 200 amp MOSFETs. And so 5 in parallel, that would be, 1,000 amps max, right? So 600 amps continuous should be no problem. Yeah, generally very pleased with this design. This is a pretty solid design. Yeah, definitely like this design a great deal. So good job, XZS. Anyway, folks, hope that helps you out. Take care and talk to you soon, hopefully.